The importance of ESD protection.
Hello and welcome to Paul McGee Electronics. I'm Paul, and in this video I'm going to discuss the importance of protection against electrostatic discharge when working on electronics, especially semiconductor electronics. So, without further ado, I'll show you how my desk is actually set up. Okay, this is my desk at home for when I'm working on anything, pretty much. I've got a soldering iron which is in fact, it claims to be ESD safe. I did a continuity test of the ground side of the soldering station and found that from the very tip of the soldering iron to ground there's continuity. That's ground all the way to the mains plug, which is connected just under my radio operating desk, which you will probably see more of in my amateur radio channel. I'll just point out that this will apply equally to amateur radio as it does to anything else, because modern amateur radio gear in fact does have a lot of electronics in it, although I'm not planning on opening anything up to show that. So I've got this blue mat on my desk, which I bought from Maplin a couple of years ago in order to be able to work on, well, anything sensitive such as computer components. When I bought it, the information on Maplin's website, which is unfortunately no longer online due to Maplin going out of business last year, they said that this mat in question was actually, well, the entire kit that it came with was actually approved by British Telecom, or OpenReach as they like to be called these days. The British Telecom bit being the actual service provider rather than the network owner. So I've got this as well, which is an anti-static wrist strap, which I've actually connected to the mat. There's a position on the mat to connect that up. That goes on your dominant hand. I'll just hang that up. So when you're working on anything static sensitive, if you're connected to ground, and you shouldn't cause any damage to it. Now, what I mean by that kind of thing, I will find an example which I will just grab by the edges because I'm not actually grounded. There we go. Now, you'll recognise this board, although minus the heatsink, because I actually took the heatsink off. This is the old broken logic board from the TV I repaired in the first video that this channel ever had. I'm grabbing it by a piece of plastic here around the common interface connection. That way I'm not in contact with the actual PCB or any sensitive components. The static sensitive components will most likely be all the chips around here. I'm not going to touch any of them, because otherwise that will, this chip there, the main processor for this board there, I'm just touching the top of the housing, I'm not actually touching anything electrically conductive, and this little chip here and the little flash chip there, which I believe is actually the point of failure on this, although I've not actually bothered to look into that. Just touching any of the pins underneath with your bare hand would probably cause the same sort of problem as well, and it only requires a very small voltage, say in the region of about, I'd say not even maybe not even 30 volts. Just a small voltage, you wouldn't even know it happened. About 2,000 or 4,000 volts, you'll probably hear it, be a little small click. And I think anything up to about 6,000 off the top of my head, might be more, you could actually see a tiny little spark. And believe me, static shocks do hurt if you somehow transfer that static between one person and another. So another item which I'm grabbing by the metal bracket is this computer sound card, which is based on a CMI 8738, I believe. Yeah, I can't see that very well because there's a lot of muck on the chip. Yes, it is indeed, it's 8738, because I do buy those sound cards because I think they're actually pretty decent. It's covered in dust because it has been in a computer, and at the moment it's not in an ESD bag, which it really ought to be, to keep it protected. But it's not been anywhere near anything that's going to cause damage to it, so it should still work in theory. So what I've done for the grounding is I've obviously connected the mat to ground via the most convenient ground point. Now that could be anything metal, it could be radiator water pipe, which all the radiator pipes in here are actually covered with plastic conduit and also they're painted, so no real direct connection to them. The only other point of connection to the ground is through the ground connection on the power sockets under the bench. I've got a special adapter plug that does that, which has got loads of resistors in, so A, dissipates the ESD to ground safely and slowly, and B, I don't get an electric shock. So that's all nice and safe. I think they're in the region of about 10 megohm. I think I did measure them, but I can't remember the exact reading. I think it was somewhere in the region of about 10 megohm. So either way, it's quite a high resistance. And if anything comes back, it shouldn't really be too much current to cause you any harm. So it's all connected up. The soldering station's connected on to its power socket. That's running ESD to ground. Continuity is through the tip of the soldering iron here, although this soldering iron tip I think could use to be replaced. I've checked it all, it's all conductive through. So if I'm working on anything ESD sensitive on this desk, the first thing I will do is, before I even touch it, is put this onto, I'm right-handed, so this goes on my dominant wrist, like so, and therefore I can then work knowing that I won't damage my components. Now I've got a woolly jumper on today. That's not specific for the video. That's just coincidence. But I've got a jumper like this, woolen jumper, rubber balloon or something on it. Then put it up your hair. And your hair's attracted to the balloon. That's an example of static electricity. And it's when that discharges, that's when that causes the problem. So my advice would be to take care. So a mat like this, you might be able to get it off Amazon. I've not seen these on Amazon because I've not searched for them because I've not needed another one. This one's sufficient enough. The wrist straps you should also be able to get from Amazon, and the cabling to connect it all up, and the special bonding plug that allows you to just plug it into the mains. I'm not sure if they're available in pin configurations for all countries, but I certainly know they're available in the pin configuration for British Standard 1363, which is the sockets used in the United Kingdom and a couple of other countries as well. So the wires should also be available on places like eBay and Amazon. So, and I think that just about covers it. I've got another video coming up on the LED lights. I've already filmed a version of that, but it didn't come out very well as I would have liked, so I'm going to obviously refilm that as soon as I can. So that's obviously the next thing I'm going to be doing, the LED lights with the solar panels that get from B&M. That's my next video. So I could go into more depth on ESD. There's an article on Wikipedia about that, a couple of articles on Wikipedia about that, which I will link to in the video description. So, and I'm also going to try and maybe get a few demonstrations on how to build kits and things. Maybe put a few ESD sensitive components in there just for good measure, just to show this thing actually in action. And you may remember the last thing I had to try and do anything that had anything ESD sensitive in, which would have been the television. I had to find something that was connected to ground just to discharge myself, which was a computer chassis, which was which is all well and good, but this is a much better setup. So, all in all, take adequate precautions and then you won't damage your equipment. I know a lot of people like to do projects with the Raspberry Pi single board computer. This is a Model B, original Model B, built in Wales. Now this one doesn't work anymore, but that's actually because I may have put too much electricity through it. I think I put 9 volts through instead of 5 volts, but that was a regulator failure which I didn't really know much about until too late. But as you can see, it's covered with electrostatic sensitive components, voltage regulators, the main processor with the RAM on top of it, a USB hub card with the Ethernet controller on it, and those little tiny transistors on the underside as well, and they're even more susceptible to damage. So if you've got the modern version of the Raspberry Pi, it's advised you use appropriate electrostatic discharge prevention, which just needs to be one of these wrist straps connected to a suitable point to ground. Just a pipe, radiator pipe, or a computer chassis that's plugged into ground should be fine. So that way your project will work. Let's go on to another thing as well. This isn't something else that would have sensitive components on it. This is a 2-line LCD display, which I have used for a project, as you can see. I just wired it up with a little card made out of some Vero board and these wires. On the back there's a couple of like chip on board type things. They could be quite easily damaged, and then the display may not work again, which wouldn't really be much good for your project if you wanted to build it into a project of some sort. So when you're working with things like resistors and capacitors and connectors and wires, you shouldn't need to worry too much about ESD. It's just some of the more sensitive components you may need to worry about it. So that's really all there is. So it doesn't matter about your tools whether they're protected or not, because as long as you're wearing the wrist strap and your tools actually have insulated plastic handles, these do, then you should be good, because that way the path the electricity will flow is not through the tool, but through the wire connected to your wrist and then straight down to ground. So there's just just very important. And as I said, it applies to amateur radio as well, which is my primary hobby, because a lot of modern radios, as I say, will have sensitive components in them, especially some of the really new ones. I've had a couple of them open, and yeah, some of them have a lot of components in there which, if you're not careful, you will damage if you just start poking around with your hand. Right, so that should be the ESD covered. I will do a bit more on this subject another time, but for now, the next video coming up will be about the cheap LED strings from B&M. That's basically just a string of LED lights which you put in your garden during the summer that are powered by a solar panel. So that'll be next video going on, and until that one's actually up, I'll get this one up. So until the next one.
Don't forget to subscribe to Paul McGee Electronics and ring the bell if you'd like to be notified about new videos as I upload them. Until the next one.